Hello and welcome. I am Vishwanath M. In this video, let us try to understand and learn the third program of Artificial Intelligence and Machine Learning Laboratory. The program name is Candidate Elimination Algorithm. Now this program is normally seen as the toughest or one of the programs which is the most difficult to understand and memorize. Memorizing the entire program is very difficult and it is not advisable. So on this respect, let us try to understand as much as possible so that even if we try to read it at the end, by knowing a few parts it will be easier. Many people even think of skipping this program. In that case, this video might make you think over. Okay, now candidate elimination algorithm, what does it basically do? This algorithm is very important even in the theory point of view, theory exams. This algorithm will definitely be asked, and we will be asked to even solve the problem. Basically, the algorithm has to return what we call as G and S. Now, G stands for general hypothesis, S stands for specific hypothesis. Before studying candidate elimination, we are usually exposed to what is called as find-S algorithm. Find-S is a much simpler algorithm which finds the most specific hypothesis. Okay, now that is the basic introduction. Now, in this program, you will find many variations available, but what is the common problem in all those other programs which we find are, it doesn't give you the correct output in cases where the first row in the training example will have a negative value. Now that is the common drawback of all the shorter programs which we find, and in case we use those programs, and if the dataset is given in which the first row is negative, we will definitely not get the correct output. So that is why it is normally suggested to learn the program which satisfies for any of the test case, that is the dataset which contains negative or positive in the first row. That is the just a matter of fact to know. Okay, coming to the program. Now basically we have to import statements, random and CSV. Random is not actually used, but we are just importing. CSV is a module which we are using to open the CSV file. Now this training examples.csv is a dataset which will be given in the exam. So this part of the code, we will just open it as a CSV file, and in Python, every square bracket means a list, and normally a curly braces means dictionary or a set, and flower braces means tuple. This is a very important prerequisite to know. Okay, now examples is the variable. So what we are finally having is a list. So you can see that we see a square bracket at the outermost region, but what we do inside is, for line in csv.reader. So this csv.reader is a function which will open the CSV file, and it will access each line. So this is each line, and it will create this as a tuple and ultimately store it in the list. So this is what examples is all about. So I have just printed this. In the exam we need not print it, that is why I commented it out. Okay, now the example is having the data set given in the form of list of tuples. This is important. Now next we have a function called as get domains. Get domains, as the name indicates, it will return a list which will have the possible values of each domain. Now what is a domain? So this is first domain, second domain. So what I mean to say is, every column is a domain, and the last column is the target value, or what we call as concept value. Concept value can take only Boolean values, that is yes or no, true or false, 0 or 1, or things like that. In some data sets this can be no, no, and this can be yes, yes. So depending on that, we will have to make a little change in the program. Normally it will be ny, or it will be yes, no. Okay, now what we are doing in the first line in the function here is, in the examples uh, variable, that is it is a list, and we are accessing the first item in the list, and then for every item in the first item, that is for every item in the tuple, what we do is we process it as a set. Okay, and then by accessing every row using this enumerate function, what we do is we add the value, that is this is the value of the first column. It can be rainy, it can be sunny, in the next third row it is sunny again, so it is like that. So we just add. While adding, if it is not already existing, only then we add. That is the functionality of add. And then before returning, what we do is we return it as a sorted list. That is the key factor here. So suppose in the data set we had this row, the second row as the first row, then obviously we would have got first value as sunny, and then we would have got rainy. But then before returning, we would sort it, and then we will return the list. So this is what this function will return. Again, this function, this whatever output we are seeing, it need not be executed and shown. Just for the sake of explanation, I have called this function here and got the output, and I have commented it out later. Now we are done with 25% of the program. Now next we have a few functions: consistent, minimal generalizations, minimal specializations, generalizes, specialize G. So these are the bare minimum functions which have to be returned. So before understanding these functions, let us come to the main function, that is the main algorithm. This algorithm is easy to code because it is more or less like the theory algorithm we study for writing in our normal theory exams. So what we are doing here is, in candidate elimination function, that is the function name or the algorithm name, we are just it is accepting one parameter, that is examples. We know that examples is the data set given. What we are initially extracting is, we are creating a variable called as domains, and we are just getting domains from the given data set. What does this mean? So we are getting all the domains except the last column, that is the last domain. So here in the data set, so there are actually 7 columns. By using this slicing operator, this is basically slicing. Before the column we have not specified anything, that means from starting till the last, but not the last column. That is the meaning of this. So basically this domain, except the last column, that is yes or no column, it will have all the other domains or the attributes, or we can even consider it as column names. Next, we know that the function has to basically return or print two things, that is G and S. Initially G will be question mark, that is question mark means, as you can see here, so there are 6 question marks. That means to say, for each of the attribute, so this is first domain, second domain, things like that. So for each of the attribute, we are initially the value as question mark. That means for any value of the attribute, the general hypothesis says that for any value of the attribute, the target value will be yes, that is positive. That is what the meaning of the question mark here in the context of general hypothesis is. Similarly, this phi symbol we need to actually type the code on Microsoft Word or something, or in the symbol table of Microsoft Word, and then copy it here. To avoid complications, we can simply replace this by any other symbol. Maybe we can use 0. That is not a problem. So initially we are just creating a, so here again we need to observe G is actually a set, but inside that set it is containing, see, the set symbol is dictionary, and inside that it is creating tuple. So this round braces or the normal brackets indicate tuple. So it is having a tuple of question marks. How many are there? That is length of domains. So we have 6 columns other than the last column, so it is multiplied by 6, and the G and S are created. This is the first step, that is G naught and S naught. We need to remember and understand that In any candidate elimination algorithm problem, the G0 and S0 value will always be same. G0 will always have question marks, S0 will always have 5 symbols. You can even replace 5 with 0 or any other symbol. In some programs you may see they will use at symbol. So this is about it. Now, so we are just printing it. After printing, this is where the algorithm starts. So this is basically the implementation of candidate elimination algorithm. In the theory exam, we usually study it in the form of a paragraph. The translation of that English paragraph to Python looks something like this. So this is just a variable name xcx. There is a reason why we have chosen xcx like this. We will just come to it a little later. So we are just examining all the rows, and now see, xcx means x is storing the list of all values in the row. That means the values of the 6 attributes or the 6 column names, and cx is storing the target value or the concept value. In other words, the value of the last column, whether it is yes or no. That is what each of the values, each of the variables x and cx are storing. The same can be understood here. xcx of everything other than the last column is stored in x. xcx of the last column is stored in cx. That is what this line of code means. So if we go through the algorithm, we will come to see that we will see the target value. What if it is a positive example, we do something, we will just come to it, and if it is a negative example, we do something else. So basically, in a way, to summarize it, we either see whether the example is positive or negative. By positive I mean the last column is yes or y. That is very that is a basic understanding. Now, if a example is positive, that is if cx is equals to y, then what we do is we don't usually change g. That is general hypothesis. We usually retain it, making sure that it is having only the consistent hypothesis. This is important. Okay, and what we do is we generalize the specific hypothesis. So this is a little tricky. That is why the program is normally perceived to be very tricky and difficult to learn. So yes is actually the most specific or the specific hypothesis set. So what we are doing is we are generalizing the specific set. Okay, and generalize s is a function. We will just see it now. So generalize yes, we will pass 3 parameters. First is x. X is the values. That is the x is having the values of the attributes or values of the domains. That is in x. G and s are the general hypothesis and specific hypothesis respectively. Now what this generalize of yes is doing, we will see here. Now generalize of yes, as I said, it will generalize the specific hypothesis. Now so before generalizing it, it has to copy it. So we will just create a variable s previous is equals to list of s. We are copying it, and so we are traversing it. Every hypothesis in the sprev. So this is just a condition which will never actually run, but we are just making sure that the program doesn't run into errors. So we put this line of code. If it is not in yes, so we'll just continue. Okay. Otherwise, now if a given hypothesis is not consistent, if it is not consistent, what we must do? We must remove it. After removing it, whatever the earlier hypothesis was there, we must add the minimal generalizations of that particular hypothesis. What I mean to say is, earlier this was 5, all the values were 5, that is null. So this was most specific. So in the next iteration, what we must do is, we must add the minimal generalization of the hypothesis. Okay. So now there is a function called as minimal generalizations of s comma x. So this function is defined here, minimal generalizations. So what we do here is, it will take 2 parameters, h and x. Okay, now here what we can see is x is like the earlier x is the hypothesis which the function or the which the function has received as a parameter, and s is what we are traversing. So when we call this minimal generalizations, yes, that is the first parameter. So we are just checking, we are just returning the minimal generalization of s with respect to x, something like that. Okay, now we are creating a list h new of h. By initializing this h new, we'll have the value of h. H is the hypothesis we sent in the form of s. So s is becoming h here. H is like the attribute which is receiving s. Okay, now we put a for loop and we traverse the hypothesis. So if it is not consistent, that is what we are doing here. If not consistent of h of I to I plus 1. Now this looks complicated in the sense we may think why is it ever needed. H of I to I plus 1 is nothing but h of I. X to I to I plus 1 is nothing but x of I. But we need it if we use it in the form of slicing, that is if we pass this, if we call this consistent function with in this method, that is h of I to I plus 1. So we are passing a list here, we are passing a list here. The function prototype of consistent we can see here, it is actually a list. h1 and h2 should be a list. We will come to it a little later. Now, so this is like we just need to remember that it should be I to I plus 1. But the understanding is it is nothing but h of I and x of I. So if it is not consistent, what we are making is, so the h new, we will, so if something is not consistent, so what we do, we replace this file with question mark. So like whatever was there earlier, we will put it as question mark. That means we are generalizing it. That is what we are doing, minimal generalization. So if it was phi, if what I mean to say here is, if h of I is phi, that is null, then simply put it as question mark. But if it is not phi, if it is something else, that is if x is something, if x of I is something else, that is if h of I is not phi, then whatever value is present in x of y, we put it to h new. This is the basic understanding. So it will be either question mark or it will be the value in x of y. And so this function, this for loop will run through the length of h, that is it will traverse the entire hypothesis and it will return the list. Again here we are actually returning a list, but inside it is a tuple. We are returning list of tuples. That is understanding. List inside the tuple function. Okay, now we have come till here, minimal generalizations. After this, so this we are storing it in the variable s plus. Now what this what does this s dot update function do? Update and difference update, they are functions defined for lists where s is an update function. S is a function, I mean update is a function which will add a given parameter, that is the update will take some parameter, it will add it to the calling parameter, that is calling variable. So s is the calling variable. On s we will call update function. Whatever is there, it will just add to it, and it will, the value of the contents of s will be updated. It is not returning anything. That is the understanding of update function. It is a built-in function for lists. And similarly, we will come to difference update just now. So s dot update, what we do inside. So this is the tricky part. So s plus, we have already got the minimal generalizations of s with respect to x. Okay. Now what we do is, for h in s plus, if any is a built-in function of Python, any will actually return true or false. That is, it is returning a boolean value. So what it will do, if in this, if in the general hypothesis G, if any of those hypotheses is consistent with H, that is what we are doing. If for G in G, we are considering every hypothesis in G, and we are calling the function consistent of G with respect to H. and then that is h is created here. So this is the tricky part. We must the execution goes like this, something like this. Now s dot update, so this is the function. What we do is for h in s plus, so h is created, h is like each iterator in s plus is what we got here, and then we compare, or we call this consistent function for every g in g. So we are calling the function consistent to see if g is consistent with h, and only then we will update it. This is what we do in the first step. Then s dot difference update. Difference update is slightly different from update. That means difference update means it will add this value, whatever is there inside this, that is whatever it takes it as parameter, it will add to s only if this whatever is we are passing is not already existing in s. That is the job of the difference update function. It is also a built-in function. Now the contents inside this function is more or less similar, because learning generalize s properly, we will in a way be able to write this specialized g also. So again we just traverse the s now, because s plus is no longer required. In whatever s plus had to give, we have put it in the s with this condition. Next we are traversing s again because it is already updated, and we do this condition. Now here what we are again doing, see, for we are just adding, or we are just updating the hypothesis. So here h is created first, then h1 is created. If h is not equals to h1, that is if the same hypothesis is not, if the hypothesis is not same, that is h is not equal to h1, we just add it to s. That is a difference update function, and then we return the s. What is s? It is the set of most specific hypothesis. This is generalized s. All this happens when we call this function s is equals to generalize s of x comma g comma s. It will sound a little tricky, but this program needs little time to understand, and memorizing this program is very difficult. So all this story for the case when the the particular example is positive, that is when it has y as the target value. If it is negative, it is just the reverse of this. So we just keep the s unchanged, and we specialize the generalized hypothesis. That is the, as I said, s is specific, so we generalize the specific thing, and g is general, so we specialize the general thing. Again, specialized g is a function. The function, the content of the function, or the definition of the function is more or less similar, like we can compare and understand. So we are basically specializing g. We can understand it better now. Like this was g in the beginning, g naught was just question mark for everything. This is like very vague. It means to say for any value of any of the columns, it will be positive, which is not true, which will not be possible. You can see here in the data set, sometimes it is no, sometimes it is yes. So this g naught will never be true. So if you see g1, what it will do, some particular column it will specialize. So by specializing, I mean we are just specifying something. That is a basic meaning of specializing and generalizing. So if we replace question mark with something, then it is specialization. And if we replace some either null value, or if we replace some specific value with a question mark, that is generalization. That is the basic understanding. So now we have explored, or we have understood what this specialized g does. Specialized g can be understood by understanding generalized s. It is more or less similar, just a few opposites, like whatever we do it here, in a way we do it the opposite way. Okay, after understanding this generalizing and specializing, so here in this specialized g, it will call another function which is minimal specializations. So here we did minimal generalization, here we are doing minimal specialization. Again, minimal specialization is a function similar to minimal generalizations. So if just to understand it a little better, the comment line says that it will return consistent minimal specialization of given hypothesis. That means the given hypothesis is it is already taken in the form of this H, and the domains it will take domains as a parameter. Now what it will return is, first of all, it should be consistent and it should be minimal specialization. That means it is, as of now it is general, so we will specialize it, minimal specialization of the given hypothesis. Okay, so we are just creating a variable called results, and we are creating an empty list. We do the traversal for the hypothesis received for I in range of len of H if it is question mark. So as I said, we are specializing it. So if it is question mark, that means it is the most general. What we do is we are specializing it. That is, here you can see here, we the H new value will be whatever it was earlier, the same thing will be retained up to that particular column, then value will be added. In other words, you can see here, you can see here the one second. In minimal specialization, see, specialized G is actually called to manipulate G, that is in negative example. So we will just see here. It was question mark in the first case, that is in G naught. So this is what is happening here. So it will see if it is a question mark, and it will retain the other values, the values for the attributes which are already consistent, and it will replace that particular value with whatever is the value in X. It sounds a little tricky, but this part of the code in this minimal generalizations, the whole thing it is doing is we are just returning a minimal specialization of the given hypothesis. If it is a question mark, we are adding value to it, and if it is 5, that is, if we are adding, if it is already 5, that is, it is most specific already, we can do nothing, because the basic purpose of this minimal specialization is we are making it from general to specialized, that is specific. If it is already specific, most specific, that is null, we can do nothing. So we will just copy the contents as it is, and 5 will be retained, and rest of the contents after that particular column is also retained, and we will return the results. So this generalized S will be called in minimal specialized G, and generalized S will be called in the candidate elimination function. So this will happen for each of the row in the data set, that is for CX in examples, for each row this will happen. And in other words, for after examining each row, we are printing G of the example number. So G naught and S naught is what we have before seeing the data set itself. So this is, we can ignore it, in the sense it is always common. After that, for every row in the data set, we print G of 1 and S of 1 value. Ultimately, we will see that initially it was G naught is equals to question mark for all the attributes. It will ultimately become, it will still be the very general hypothesis, many question marks will be still there, but some particular attribute would be specific. And in case of S naught, it will be most specific, that is, it will have null values for all the attributes. At the end, some of the attributes will have question mark. That means we have, in a way, slightly generalized the most specific hypothesis. So just to verify, G of 4 and S of 4. Now let us see S of 4. It says sunny, warm, strong. So these are the required attributes. That is, these are the values it should be present for the hypothesis to be positive. Now let us see sunny, warm, strong. In the data set, wherever there is sunny, warm and strong, it is always Y. Okay, sunny, warm, strong, sunny, warm, strong, sunny, warm and strong. It is always positive. And the general hypothesis says it should be either the first attribute should always be sunny, and or else if the second attribute, if it is always warm, then it will be positive. That is what is being told in the general hypothesis. Now it can be, when it is sunny, it says it is positive, and when it is warm in the second attribute, it says it can be positive. Wherever it can be warm or it can be sunny, it should be positive. And when it is neither sunny nor it is warm, it will always give a negative concept value or the target value. So this is all about the candidate elimination algorithm. Slightly complex and difficult to learn, but spending a good amount of time, we will be able to learn it. That's all for this video.